So we're going to talk about lesson 52, maximization and minimization problems.
Oh my gosh.
Okay, maximum minimum problems. We did look at varieties of these earlier this year. Honestly, off the top of my head, I'm not even remembering exactly what we looked at or how we solved them, but we have seen some of this set up, especially like this whole idea of rectangular field, one side being fence. We've looked at this a little bit. So maximum minimum problems can be used to can be solved using derivatives. Because here's the deal. If you're trying to find the max or the minimum in a certain situation, a maximum or a minimum can be found by finding your critical points. And your critical points are found with your first derivative, right? So that's what we're looking at here. The critical values will determine relative maximums, minimums, and these will then be the answers to some of life's trickiest problems, as it's stated here. But these problems can also be done by graphing the original equation and finding the maximum value on a calculator. This right here, like what we're getting ready to do, would be more of a non-calculator problem on AP. Okay, because yes, you could look at it on a calculator, but the way we're going to do it, we wouldn't need a calculator. Okay, Mr. Wallen has 100 yards of fence. He wants to form a rectangular field enclosed on 3 sides by the fence and on 1 side by a river whose banks are straight, because all rivers have straight banks. Find the greatest area that the fence can enclose. Okay, so let's see, given information. He has 100 yards of fence we're going to use in this problem. He's wanting to form a rectangular field enclosed on 3 sides by fence and 1 side by the river. And we're being asked to find greatest area. So we're being asked to maximize area is what we're being asked to do here. Okay, so I'm going to start with a picture here. I've got my rectangle here. Three sides being the fence and the long side being the river. I can do a little bit of labeling for you there. Okay, let's see. We're trying to maximize area, yes? So as we try and maximize area, what do you know about area? Length times width. Okay. So, which way do I want to do this? We have 2 sides that are the same, and we have 1 side that's different. And that 4th side we don't care about. So what I'm going to do is I'm going to use x for the width of this rectangle. Okay. So I'm going to use x for the width. I think I'll even write that up there. And then we also know that there are 100 yards of fence, correct? Now this other side, I'm going to call y for the moment. But here's the deal. When we set up our area equation and we're going to have to take the derivative because we're trying to find critical points, we need 1 variable. So we can't say x times y equals the area. We can't do that. We need it in 1 variable.
So we need to find y in terms of x.
So we need to find y in terms of x. What's the other piece of information provided that connects x and y? Yeah, 100, right? Because there's 100 yards of fence, and what's going to equal 100 yards of fence?
2x.
Okay, and I was just trying to write x plus y equals 100. So yes, 2x plus y equals 100. So the whole reason they told us that 100 yards of fence is because that's the connecting feature there. Okay? If I want to solve that in terms of y, we know y is, I just wrote 100 minus 2x. Obviously, you could also write negative 2x plus 100 if you prefer. So now, if I did say my rectangle has sides of x, x, and y, I could now say my rectangle has sides of x, x, and 100 minus 2x. Huh?
Lag for a second.
My BenQ is having an issue. I think my BenQ must need restarted because there's a lot of lags and weird stuff going on with my BenQ today.
All your technology.
Well,
It is.
a-
It's not
It was
good.
an internet problem last night. Doc was talking about
It,
it. It's-
during the day yesterday.
Yeah.
And that didn't really affect me other than Math Excel. I had a gateway error, but my students weren't using Math Excel yesterday, so it was fine. But yeah, I don't know. My BenQ is really doing some funky stuff, so I'm guessing it just needs restarted. But that's not for during the middle of the day. At least not if possible. Okay, so we're trying to maximize area. So I'm going to set this up. I'm going to say A of X, just to be formal. If you just want to say A, you could say A. And that area, in terms of X, how am I going to write the area?
X times 100 minus 2x.
X times 100 minus 2x. Knowing that this is a maximum minimization problem and I'm going to be having to do derivatives, I would encourage you to go ahead and multiply that together. And x times 100 minus 2x is 100x minus 2x squared. Okay. So, if we want to find where it maximizes, okay, I need to find the derivative and do what with that derivative? Set it equal to 0. Okay, so what's the derivative of 100x minus 2x squared? Or I guess you guys may have it the other way around, but I have 100 minus 4x. I'm going to take that 100 minus 4x, set it equal to 0. I'm going to do some math type stuff.
Yes, do some math types.
Hey, you know what? Do I really need to solve this equation for you for x?
No.
I better not. Not if you have made it this far. Okay, so I'm going to do my math stuff here.
See, now that's like straight up took forever, like didn't even register.
Well, I think my arm might have touched the graph, and if you or the board, if you touch the board in two different spots, it won't do it. But okay, so I subtracted 100. I'm going to divide by -4, and x is 25, right? Okay.
Can we plug x back into the area equation?
Well, okay, so a couple of different things here. I'm trying to decide. Officially, keep in mind it is possible that we would get more than one critical point. Okay, in this case, we only got one critical point, which kind of makes life easier because it's going to have to happen there or we have something going, totally wrong here. But let's see. So what we know right now is that when we do the derivative, okay, so a couple of things here. When we do the derivative, evaluated at 25, that's going to equal 0, yes? Because that was a critical point. So we need to, okay, the derivative, what this tells me right here is the derivative evaluated at 25 is going to equal 0. To show that this is a maximum, we have to do something to kind of show that it's a maximum. And we just talked about the second derivative test the other day. Okay, I mean right here, the first derivative at this point equals 0. So we know the first derivative tells me it's a critical point.
Okay, and then the concave of the second one is going to tell you if it's a max or min.
Right, the concavity can verify whether it is a max or a min. So the idea being, we had our first derivative here. What about a second derivative? What is the second derivative? Second derivative is negative 4. So what is the second derivative when I evaluate it at 25? Or in other words, when I plug in 25? It's still negative 4. In other words, the second derivative is always negative 4. And so, yeah, the point that I was trying to get to, and we kind of already talked about it, my second derivative is always, or in this case, it is negative. And a negative second derivative means concave down. And if a graph is concave down, that means it's fold upside down. And so that means there's going to be a max. Okay, so that's kind of your proof. You can't just say, oh, hey, I got this critical point at 25. That's the only one. It has to be the max. You need to have ways to verify, and that's one way. That's one way to verify. See that it was a negative parabola, so it's an upside down parabola. I mean, I want to say yes, but does that work for calculus? Like, you know, like if we're talking about like an open-ended calculus question, does that justification work like on the AP test? I'm not 100% sure. I mean, you know, if you want me to be honest, I'm not 100% sure. I get it. It makes sense. The justification makes sense, but yeah. And here, I mean, and here's the deal. We only had one this time, right? What if we had multiples?
We'd have to test which one was not.
Yeah, you'd have to figure it out past that. So, okay, now,
And what's the area?
we have not actually answered the actual question with all of this. What was the question?
Find the greatest area.
We have not answered finding the greatest area. So where does the greatest area occur?
25.
At 25. What do I do with 25 to find the greatest area?
Plug it into the area equation.
Plug it into your original equation. So you're trying to find the area when x equals 25. So plug them into, I don't know, one of your original equations there. I think I'm going to use the factored form of 25 times 100 minus 2 times 25, which is 25 times 50. And 25 times 50, 5 25s is 125. Tack on a 0. 1,250
Square yards.
square yards.
Yeah, that's not bad.
Okay. And I get it. I mean, shortcut wise, oh, hey, 25 is a critical point, so plug in 25. My area is 1,250. However, you know, you got to prepare for bigger problems. We've got to know the calculus behind it. And so that's where we can use our second derivative test from the other day and look at the concavity.
What if it wasn't a max?
I can't say that I've ever seen a problem that says find the greatest area and then you end up with a minimum. Like, I can't say that I've ever seen that happen. So I don't.
From a logical standpoint, this makes sense too, because logically speaking, if it was 25 width and 50 length, that's the most you can make with 100 yards of fence. And one side already taken by everyone.
Yeah. So, okay. Moving on. Okay. Example 2. Find two positive numbers whose sum is 8 and whose product is a maximum. So, two positive numbers, sum is 8, product is a max. That's the information I see. So, two positive numbers whose sum is 8. What equation can be written to connect those?
X plus Y equals 8.
Easy enough? Okay. So we don't know anything about the numbers other than they have to be positive. We can't really, we don't want to get fancy and try and say absolute value of anything, you know. And actually, X and Y themselves would have to be positive. So it's not even about absolute value. So we just, the whole positive restriction, keep in the back of your brain, and we'll worry about when we get to the end. If we get a negative, we know there's an issue, okay? So positive numbers whose sum is 8, and product is a maximum. How do we find a product? Right, so I'm going to write a product is equal to xy. And I'm writing the equation for product because that's what we're trying to maximize, right? Eventually, we're going to have to take the derivative of the product equation. Now, what's my issue with my product equation currently?
It has a Y, but it needs to have only X's.
I need one variable only. So I have x and I have y, but we have a connecting equation, right? If x plus y equals 8, can I solve that one way or the other? I mean, generally we solve for y and put it in terms of x. Technically, you could do it either way. I'm going to say y is equal to 8 minus x, or negative x plus 8 if you prefer. And so then what do? Take that value and plug it in over here. So now my product equation is x times 8 minus x. I'm going to go ahead and distribute, knowing my next step. So 8x minus x squared. Because what do I need to do? Yeah, we need to find the maximum, so we're going to take the derivative. What is the derivative of 8x minus x squared? Okay, he says minus 2x plus 8. I just wrote 8 minus 2x. We know we're all on the same page here. And I'm going to take that derivative and set it equal to 0. And last time I said I was going to do some math, and you guys laughed at me, but I'm going to do more math. Did your math work out to be my math? X is 4. So what we know right now, the derivative at 4 equals 0, correct? So officially, we know at 4 that I go into a little more detail than last time, there is a critical point at 4. Officially, a critical point could be a min, a max, or an IP, inflection point. Keep in mind, though, the problems generally work out that, hey, if you're looking for a max, it ends up being a max. I don't know that I've ever seen a problem that does it the other way, or, doesn't work out like that. Now, how do I confirm? Told you my BenQ is doing weird things. I think it just needs restarted. Sometimes it just lags, sometimes it draws not what I drew. Okay. How do I confirm this is a max? Second derivative, yes? So, what is the second derivative? -2. And so that means the second derivative evaluated at 4 is also -2. So there's no evaluation needed. If there's evaluation, obviously you'd have to evaluate it. -2 is a negative. Because it's negative, that says what? concave down. Concave down tells me there's a max. So, find two positive numbers whose sum is 8 and product is a maximum. Well, we know one of the numbers, right? One of the numbers is 4, because that's my max. X is 4. Well, what do we know? When X is 4, what is Y? Also 4. So in this case, the two positive numbers are 4 and 4. Yeah. Well, yeah, and that's essentially what I did without really saying it is, yeah. If X plus Y is 8 and X is 4, then, yep. Okay. Did I get everything there? Okay. Ready for the next one? It's our last one, isn't it? Right? Yeah. Probably has the most words, though, too, doesn't it?
Yeah, and it's supposed to work.
Of course it has the most work. It's the last one. Okay. Although part of the scenario should sound familiar. Make an open top cardboard box by cutting squares, X inches on a side, from each corner of a 12 by 15 piece of cardboard and folding up the edges. So this is where you take a full piece of cardboard, you cut out the corners, and it makes a lid in this case. Or I think it was no, I guess it makes the box. Find the value of X that results in the largest possible volume and find the volume of that box. What do they ask me to find here? Largest possible volume, so they're actually asking me to maximize because they're asking me to find largest. Okay, let's start with a picture. Or maybe you're not starting with a picture, but I'm starting with a picture in case you need it as review. So this piece of cardboard is it's not what I wrote. (12 by 15), yes. And then what are we doing? We're cutting out all the little corners. And as we cut out all those little corners, each of those little corners are X by X, right? So do you remember how this works? What is the actual length of this box? Okay, so it's the original 15, take off the two corners, so 15 minus 2x. And that means the width is 12 minus 2x. Because it was 12, you take off those two corners that are x in length. So 12 minus 2x. Okay. So that's what we know about our box. We are trying to maximize what? Volume. What do you know about volume of a box? Length times width times height. What do we have in the way of length times width times height? Oh, yes, we do. Okay, so the length of the box is the 15 minus 2x. The width of the box is 12 minus 2x. And the one that you may have to think about, the height of the box. When you take those flaps and you fold them up, that makes the height of the box. How tall are those flaps? They are x. knowing that we're going to have to take derivative eventually. We don't want to leave this in this form. We want to multiply it out. Okay? So basically, there's two parentheses that you need to FOIL and then distribute in the x. Are we talented enough we can do that all at once? So if we start FOILing, 15 times 12 is
20.
180. And then if I go ahead and distribute in the x, I'm going to say times x. And then if I do my outsides and insides, minus 30x and minus 24x. Minus 30x and minus 24x is going to be minus 54x. Distribute in the x makes it x squared. Minus 2x times minus 2x plus 4x squared. Distribute in the x makes it 4x cubed. We can handle that at this level, right? Something some of you have probably been doing the last 3 years, and I just refused to do it in class until this year. Okay, what am I doing?
Have to take it.
Yeah, now we're in a better situation to take the derivative. So, derivative is did I do that right? 180x minus 108x plus 12x squared. And we have to set that equal to 0. Now, as we think about setting this equal to 0, this means we're going to have to solve it, right? I don't know if Ross figured this out because I think he's already past this point. What do all three of those pieces have in common?
An x and 12. So divide by 12 to figure out the x.
Wait a minute. Wait.
Okay, I didn't get an x.
Yeah.
There wasn't an x on it.
Okay, so
I didn't realize that. I didn't
I
realize
just didn't want to say
that.
anything.
I was sitting here worried I did it wrong, but I was like, okay, did I do it wrong?
no, when you guys start telling me there's an X in common, I was like, there is?
Even
There's-
asked us, he said, did I do that right? And he just agreed.
Although, did I read the X out loud? I don't know. Okay. So, what do all three of those numbers have in common is what I was trying to get at. They all have a 12 in common. So I would encourage you to factor out or divide that 12 out. I'm also going to flip the order on this one because of it's a quadratic. We're going to have to solve this quadratic somewhere. So I'm going to factor the 12 out. And then I'm going to have x squared minus, how many 12s is that? My mind's blanking. No, right now it's 9. X squared minus 9x, this one's 15, equals 0. So I set equal to 0. I factored the 12 out. Technically, it's setting equal to 0. We could divide the 12 away. Because it's an equation, you can divide both sides of the equation by 12, and that 12 doesn't even have to be there. Okay, so really what we need to be concerned about is x squared minus 9x plus 15 equals 0. What's the unfortunate realization?
It doesn't factor.
It doesn't factor. You can't get a product of 15 and a sum of negative 9. So what's backup plan?
So the little quadratic formula
Quadratic formula.
for all them years.
It still hangs around. Now, Mike, did you do the quadratic formula, or did you stop here for a
I
moment?
stopped
You stopped here, unsure if you'd done it right at this point.
because I was like, that doesn't factor. Let me check.
Okay, nope, it doesn't factor. So
Formula's not.
negative b, 9 plus or minus the square root of b squared minus 4ac all over 2a. And my a value is 1, correct? because that 12 isn't really there. Or it's not, you know. So 9 plus or minus square root of 81 minus 60, which is 21, all over 2. And being on the fact that it says find the value of x that results in the largest possible volume and find the volume, we're going to have to go farther. But keep in mind, there's also 2 values here, right? We only need one of them. So,
But in theory, the link couldn't be negative, right? So it has to be the positive value that comes out of that.
well, except that they both come out positive.
That works too. So
We have to do a little bit more. So, okay, so I just grabbed my calc there to do 9 plus the square root of 21, all divided by 2. And I get 6.7913 is my 4 decimal places for Saxon book. AP, minimum 3, folks. So don't, I was tempted. I almost screwed up and said 6.79. Don't. Okay. And then I'm doing 9 minus the square root of 21. Oops, divide by 2. 2.2087. So we finally, last problem of the day, get to one where we have to go to second derivative. You can't just say, oh, well, it's, you know, it's the only one. It's got to be the max I need. And I guess you could look at some of the original problem. I mean, you could do it that way and use some logic about the graph, the fact that a positive 4x cubed would have down and up behavior. So it would start down, and there'd be a turning point in there because you're going to have a max and a min. So the max is going to come first, and then the min second. So you could do that, but again, I think you need calculus reasoning here. Okay? And the calculus reasoning says we now want to look at the second derivative. What's the second derivative?
Should we do 2x minus 8 because the reduced version, or 2x minus 9 because it's the reduced version?
Yeah, you could.
And that's what I did.
I just said the second derivative is negative 108 plus 24x. However, if you take, 108 and divide it by 24, wait a minute. What you get as your second derivative?
2x minus 9, so I don't think you can. Because I did.
Yeah, that's.
I reduced the first derivative and then took the second derivative with the reduced first derivative.
Okay. So yeah, valid point. You can't. And again, it's because if it's an equation, you can divide that 12 out. But at that point, when we're talking about the derivative, it's just an expression. Does that make sense? Sorry, my brain did not connect that at first. Okay, so second derivative. What do I need to do with the second derivative? Not put it equal to 0.
Solve it, put in those 2 values.
Put in those 2 values, right? I need to see the second derivative evaluated at 6.7913 and see what kind of value I get there. And I need to see the second derivative evaluated at 2.2087 and see what I get there. So do the math.
I have to scrooge.
Okay, so here's the deal. If you go back and use the full decimal, you get a slightly different number. Because I have written down in my notes 54.9909. When I just put in that 4-digit decimal, I have 54.9912. Although, it tells me in both cases that What do you know about this number? It is positive. And what does a positive second derivative tell me?
That it's concave down, which means
It's concave up,
we don't-
which means at 6.7913 there is a minimum. So what we hope is going to happen
but the others will be negative.
is that the other one's going to be just the opposite. Negative 54.9909 or negative 54.9912, depending. So because this is a negative second derivative, it's concave down, and concave down means there is a max. So, what's our final answer?
Have to find out the old plug thing.
Yeah. It wants the value of x and the volume, right? So we're going to use what x value?
2.2087.
Yeah, so I'm going to do the volume, evaluate at 2.2087. And we're going to find what that lovely value is. And that's your answer. I was lazy. I took the figure from my notes.
You just knew that.
Yep, you know it. You've got such an awesome calculus teacher that gosh darn it. And this is why I didn't even bother, because I got the total wrong answer just now. That's because I left out a 2. Hey, there we go. Now that's a better answer.
It's always the twos that get you.
I did. Well, I had to type in that 2.2087 multiple times, and one of the times I left off a 2. So, okay, guys. Maximization, minimization. That took longer than I thought it would.